welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom. So learn physics at your convenience. Let us start our today's lesson. The topic is mutual induction. Students, look at this circuit diagram in which two coils are placed near each other. One is connected with a variable voltage source. We call it primary coil. The other coil lying nearby is connected with a galvanometer having no voltage source or battery connected in its circuit. Students, when we switch on in the primary coil, a current starts flowing. You know that when current flows in a coil, there produces a magnetic field. So, due to flow of current in this primary coil, a magnetic field is produced. And some of the magnetic lines of force or magnetic field lines will pass through the secondary coil that is lying nearby. So, a magnetic field is shared with the secondary coil. Students, when we change the current in the primary coil by moving this variable resistor or rheostat, then the magnetic field in the primary changes, and as this field is linked with the secondary coil, so magnetic field through the secondary coil also changes. This changing magnetic field in the secondary coil produces current or EMF in the secondary coil. This phenomena is called mutual induction. How we can define it? Production of current in a coil, here in this coil, production of current in a coil due to change in current in a nearby lying coil. Means when current change in one coil produces current in a nearby lying coil, we call this phenomena as mutual induction. Now, what is the mathematical form? Again, look at this circuit. The induced EMF produced in the secondary coil is directly related with the rate at which the current is changing in the primary coil. Mathematically, we can write EMF produced in the secondary coil is directly proportional to rate of change of current in the primary coil. Removing sign of proportionality, we get the equation like this. Voltage in the secondary equals to minus M delta IP over delta T. Delta IP over delta T is the rate of change of current, how current is changing with the time in the primary coil. M is called mutual inductance of the two coils, and negative sign shows that the direction of this EMF produced or current produced in the secondary coil is such that it will oppose the cause producing it. Means if cause is increase in the current, it will try to decrease it, and if cause is decrease in the current, it will try to increase it. This is here shown with the negative sign, opposition to the cause producing it. M, I told you, is called mutual inductance. Now rearranging this equation, mutual inductance will be M equals to minus ratio of the voltage in the secondary over rate of change of current in the primary. We just rearranged this equation taking delta IP over delta T on the other side. So we get M equals to minus E in the secondary, EMF in the secondary multiplied with delta T over delta IP. Now unit of mutual inductance will be from this equation volt for EMF, second for time, ampere for current. So unit of mutual inductance will be volt second per ampere, and we call it Henry. Henry is the unit that we use for mutual inductance. How much will be 1 Henry? 1 Henry will be the mutual inductance of two coils if current changing at the rate of 1 ampere per second in a coil produces a voltage of 1 volt in a nearby lying coil. Then we will say that the mutual inductance is 1 Henry. Students, it is all about the phenomena of mutual inductance on the factors on which the mutual inductance depends. I hope it is clear. Students, thank you for sparing your time to watch this short video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.